So this is fail dot 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 almost part two. You might have been screaming at the screen if you were watching carefully. Refer to part A, okay? Don't just start watching this, right? But I said square root both sides. Square root of 4 is 2. Square root of x squared is x. And I put the square root in here. Now, I did make a comment that I should have addressed this issue of plus or minus and whether or not this makes any sense. So let me address both those issues. But the main thing was I missed that square root. Um, First off, what does this tell me right here? This tells me that the absolute value of x has got to be less than or equal to 1. So when I'm going to be making a graph of this, I only want to consider from -1 to 1 on the x-axis. Second off here, let me erase this because it's not right because I didn't write the square root sign down there. And I guess it would be sort of interesting to take you through my thought process of how I detected this, but maybe another place and another time. Well, here I'll tell you. Without the square root, I made a graph of it. And it was pretty close to the graph of that when I used Desmos to graph that. And closest, what do they say? Closest only counts in horseshoes. It does, yeah. So, I knew what I had was wrong. But the weird thing was it was kind of close. And that made me think, what on earth is going on? Because it tends to be that you'll be right or you're way off. It's a little strange to be close. And that made me go back and take a second look. So this is nothing standard, so to speak, to make a graph of. So unfortunately, for better or worse, now you can apply your calculus techniques, right? You could, hey, we could find x and y intercepts, right? 0 is an obvious intercept. And if you look at this here for a second, it's obvious that plus and minus 1 are intercepts. So there are our intercepts. We could dive into Calc 1 and do the first and second derivative test. And you'd have to make two of them, right? So one of them you would make the plus branch, and you'd want to do something similar, exactly similar, for the negative branch here, like this. And you would get increasing, decreasing, and concavity and stuff like that. And you get basically a graph that looks like this, which those of you who just went straight away and graphed the parametric equations, you already knew. A couple of nice things, again, if you took the first derivative, you would find out that it has problems at the endpoints. And if you look at this graph, not the way I graphed it, but if you graph it nice on something like Desmos and you zoom in, you'll see it actually would have a vertical asymptote here. And remember, vertical asymptote is a place where the first derivative doesn't exist or isn't defined. So, okay, that's what the graph looks like. There are the x and y intercepts. So let me go ahead with the next set of parametric equations for x and y. Okay. Oh, it also occurred to me, and maybe it occurred to you. I don't know. Maybe it occurred to you when I was doing this. I could have used an identity right here for sine of twice an angle, and it might have saved a lot of trouble. But I already did it this way. Okay, fine. My suspicion is if I had done that, it would have been less algebra involved here. So if you did it that way, kudos to you. Angry emoticon face to me. Okay. Now, question 0, part B. Start with a fresh, clean board here. X equals e to the negative t. Let's see. X equals e to the negative t, and y equals e to the negative 2t minus 1. Blah. Y equals what on earth? Okay, e to the 2t minus 1. I wonder if I copied this one out of the book. I'm not sure. Again, when I look at something like this, I'm not at all sure what it's going to look like right away. I mean, we're all pretty familiar with the exponential function. A little less so when I put a negative up here, and then I have something like this. Oh, that should be a t. Yeah, something did look funny. Okay. At least that variable needs to be the same as that. That's our parameter. Again, most of you just went straight to Desmos and got a graph of this. There, it went out of focus again. Why? Maybe it's time for an upgrade of the camera, huh? Okay. Again, the thing that occurs to me first is to solve one of those for t and substitute it in the other one. And then instead of having parametric equations, we'd have our rectangular coordinate, a regular y is a function of x style of writing this. So which one should we start with? It's not clear. I would rather do the one that's a little bit easier. Like I said, it's not completely clear which one's easier. It may not make a difference. Let's rewrite this one here. We can take the natural logarithm on both sides and get the natural logarithm of x equals negative t. And so t is equal to, oops, I wrote that right in the glare dot. Can you believe that? Yeah, well, there, nice, huh? So what do we get from taking the natural logarithm on both sides? And we get negative t is equal to the natural logarithm of x. And so t is equal to negative the natural logarithm of x. And let's substitute that in up here. So we get y is equal to e raised to the power of 2 times this. So negative 2 natural logarithm of x minus 1. Let's factor, I'm trying to simplify this because I don't know what it is right now. Let's factor out a negative 1. I don't know whether I want to do that or not, but let's go ahead and do it. So negative 2 logarithm of x plus 1. And that, I think we can anticipate kind of what it's going to look like. If we think, we could plot points and all that kind of stuff, but we know so much about the behavior of e raised to a power that we probably can anticipate what that looks like. In particular, consider the following. As x gets larger and larger and larger, the natural logarithm of x gets larger and larger and larger. Now, less and less rapidly. If you think about the graph of the natural logarithm of x, even when you multiply it by 2, nonetheless, everything in the parentheses keeps increasing as x increases. So this graph should have something in common or some similarity with e to the negative x. Now, it won't be the same as that. It won't have the same first and second derivatives. It won't have the same rate of increase. The concavity should probably be the same, though. Is there anything else we could do to simplify this? And I think the answer there is yes. Let's write it like this for a second as a little clue as to how we might want to proceed. How about let's get rid of that negative sign temporarily and write it like this: e to the 2 times the natural logarithm of x plus 1. And, we still have all our favorite rules of exponents working for us. So I can rewrite this like, look, it's e raised to this power times e raised to this power. One of the most basic all-time rules of exponents, right? And if I reorganize things a little bit, we'll have e times e to the 2 times the natural logarithm of x. Oh, and I think, look, now this is suggesting more things. First off, make sure that's right? So this is e to the 1. Same base, add the exponents, we get that. Now, look what I have here. I can write this like this. Y equals 1 over e raised to the power of the natural logarithm of x raised to the power of 2. That's one of our basic rules of exponents, right? Something raised to a power, you multiply the exponents. Well, look at this right here. E raised to the natural logarithm of x is just x. So this is y equals, hope that comes out on the screen, e times what? Times x squared. I'll put a dot in there to emphasize the fact that's multiplication. It's a number times x squared. It's a parabola. That is a really, really nice parabola. It's a particularly nice parabola, right? It's a parabola that goes to the origin, and it's a little bit steeper than y equals x squared, but, how am I going to even indicate that without graphing some points? And voila. There it is. Done deal. There's the xy intercept. There's also the vertex. We even know what it is. It's a parabola. So very nice. And then, what's the last one to graph? Hey, let me see if I can do this kind of quickly here. X equals natural logarithm of 2t. I don't want to make the videos go too long because whatever the setup I have here, it destroys it if I go on too long. It might be nice to try to get the rest of this question done on this video though. I'm hoping for the best now. Hope this works out really nice, the last one here. X equals natural logarithm of 2t. X equals, natural logarithm of 2t. And y is equal to t squared. Y is equal to t squared. Again, I want to make a substitution. Not sure which one I want to make. Let's start up here with this one right here. If I go for this, if I exponentiate both sides, so to speak, that's the same thing, or use the definition of natural logarithm. That's the same thing as this. And so t is equal to 1/2 e raised to the power of x. Let's substitute it in here. We get y equals, here, I'll write it like this, 1/2 e to the x. Let's square it. That's 1/4 times e to the 2x. Oh, and we know what that looks like. We a bunch of different ways, but that looks like this. And I think we're familiar enough with that. I don't think we need to say too much about that. When x is 0, you get e to the 0, which is 1, which is 1/4. So right there, 0, 1/4. There's an asymptote. So somehow you want to indicate, even if you just indicate it graphically, that's fine. The x-axis is an asymptote for this, and that's based on the fact we're so familiar with that. We know its behavior. We know what it looks like. There's no asymptote over here. There's the y-axis, no x-intercept. Alrighty, so there's question 1.